Hello, welcome to the channel. On this video we are going to discuss some geometry problems. The problems are taken from the book Geometry in Figures. So I think this is an excellent book and it is presented in a unique way. How so? So in the book it is presented just as the drawings of many geometry diagrams, such as similar to this one. So then our task is to decipher what the problem wants us to do and then try to prove it. So for example, in this picture, so I will represent the dashed line on the book by the red line. Okay, so here there is an indication here that it is a right angle, right? So we have a right triangle, and then we can see that there are two blue mark ticks that indicates that these two segments have the same length, right? And then finally there is this red line. This red line is usually the last thing to do in the picture. So what I meant is that once after we draw this red line, then we need to conclude something. So I forgot to put the blue mark here. Okay, so it means that we want to show that this red segment, the length of it is also equal to these two segments, because they indicates that the three of them have the same length. Okay, so to repeat the problem, given a right triangle and then we construct a line that passes through the vertex that has right angle, and then we take the line so that it intersects the midpoint of the hypotenuse. Show that the length of this segment is equal to the other two segments. So that's what we are trying to prove. Okay, so let's do it. So first of all, I'm going to make a line which is parallel to the base. Okay, so this line is parallel to the base. Because of that, then certainly this should be a right angle, right? And also by the property of parallel lines, these two angles must be equal as well. So then in particular we have two similar triangles, the smaller one and the greater one. And by the property of similar triangles we have equality between proportion of the side of the two triangles. So for example, because the two are similar, then the proportion of this to that is exactly the same to the proportion of this to that, right? Since these two are equal, therefore we conclude also that these two must be equal. Let's give it a double mark here to indicate that the two segments have the same length. Okay, so remember that our objective is to prove that this segment is of the same length to this segment or to this segment. So one way in order to achieve that is by showing that these two triangles are in fact congruent, right? So why is that? So notice that this length and that length are the same, and then the two triangles sharing this side, okay? And also the angle formed by these two sides is a right angle. Similarly here, the angle formed by these two sides is a right angle. Hence, by the side criteria, these two triangles must be congruent to each other. So then, in particular, the two hypotenuse must be of equal length. Therefore, this guy is of equal length to that guy. And we are done. Okay, so that's all for now. We are going to discuss more problems from that book. Okay, see you for now. See you again for in the next video. Bye bye.